Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 13th sum. Already in the last videos, I have uploaded up to 12 question solutions. So please go through it. Now let's start with the 13th one. So what is the given question here? Is the function defined by f of x equal to x plus 5 if x is less than or equal to 1, x minus 5 if x is greater than 1 is a continuous function. So basically the given function they're asking us to check the continuity. So whether it's a continuous or not, we have to answer. To check the continuity throughout the real function, we are not going to use a single function. So as per the if conditions, if x is less than 1 particular function we have to use. If x is greater than 1, another function we have to use. So throughout the real line, we are not going to use the single function. So that means as a part by part, we have to check the continuity. So using the if conditions, no, I'm going to break the real line. Okay. So here we can see at 1, I'm going to break. So that means in a case 1, at x equal to 1, I am going to check the continuity. And for checking the continuity, we have to check for if x is exactly 1, what is the outcome. Okay, now the close value. So continuity, how to check? The close values of 1 also, we have to get the approximate value of the f of 1. So close values of 1, infinite values we have. So it's not possible to check one by one values taking and substituting, and it's not possible. So with the help of the limits only, we can able to find out all close values at the time. Okay, so for that, for the close values of 1 from the left hand side, left hand limit we are going to take it, and for right side, right hand limit we are going to take it. Okay, if all the three, f of one value, left hand limit and right hand limit, if all the three values, if it coincide, then we can conclude that at x equal to 1 is the function is continuous. Okay, now throughout the real line. Okay, so basically the question is they are asking throughout the real line only. Okay, at particular point they didn't mention. So that means throughout the real line we have to check the continuity. At x equal to 1 we can check. If x is less than 1, that means in this particular interval we have to check the continuity. So what is this one? We can take it as a case 2 if x is less than 1. So less than 1 means infinity real values we have no in this interval. So we can, instead of taking any one particular value, considering all the values and together, we can have a common name. So let c be any real value. Now same way, f of c, left hand limit, right hand limit all together. Similarly for if x is greater than 1. Okay, so this is how we are going to proceed this sum. Now case 1, let's do it in a detail. Now case 1. So in case 1, what is the condition? If x is exactly 1. Okay, so at x equal to 1. So as per the given, if x takes the exactly 1 value, no, the suitable function is the first one. So substituting x as a 1, 1 plus 5. So that is answer is 6. Now left hand side of the close values of 1 we have to find out, and same way right hand side. Now left hand side all close value, very close values of 1, also approximately 1. Okay, but anyway, those values are less than 1. So if it is less than 1, we have to use the first function. So for the left hand limit, in place of f of x, we are going to use the first function, and the right side close values of 1 are greater than 1, approximately 1, but they are greater than 1, so we have to use the second function. So since we are going to deal with the different function, left hand limit, right hand limit separately only we have to work out. Now left hand limit x is approaching to 1 from the left side. So indication is minus sign, f of x. Now suitable f of x is what? From the given, left hand side close values are less than 1. So suitable function is x plus 5. So limit x is approaching to 1, x plus 5 replacing. Now approximately all values are what? The close values of 1 are 1 only. So replacing x as a 1. So 1 plus 5. So which is 6. Okay, now right side close values of 1, right hand limit x is approaching to 1 from the right side, f of x. So f of x is here all values are basically greater than 1. So that means we have to choose the second function. So replacing f of x as a second function, that is x minus y. So approximately all values are 1 only, no, just replacing x as a 1, 1 minus 5. So which is minus 4. Now we can see that left hand limit, right hand limit is not same. So here left hand limit and right hand limits are not equal. So from this what we can say? Is that function is continuous? Obviously not, because left hand limit, right hand limit values are mismatched. It's not matching. So we can conclude the same. Here left hand limit, right hand limit. Okay, already I have written not same. So f of x is not continuous at x equal to 1. Okay, so how about the other values? So throughout the real and at x equal to 1 the function discontinuous. So we need to check for the other intervals now. Okay, these two intervals we have to check. So case 2, if x is less than 1. Case 2, if x is less than 1. Okay, if x is less than 1, so in this particular interval infinity values are lies. Okay, so it's not possible to check one by one. So what happens if x is 0, what happens if x is minus 1? It's not possible. So we can have a common name. Let c be the any real value. At the same time it is less than 1. So let c be the any real value, but c is less than 1. Okay, now f of c we have to find out, and left hand limit, right hand limit, all three things is required. But in case if the f of x we are dealing with the same f of x now for the left hand limit, right hand limit, then together we can find out the limit. Now f of c, so c is what, less than 1, then suitable function is first function, that is x plus y. So here input is c, then this becomes c plus 5. Now limit x is approaching to c from the left side, right side. Okay, so let's see how we can take the together. Okay, how we can take it together, left hand limit, right hand limit. Now basically c is what, less than 1, that means it falls in this particular interval. So here it falls. Okay, so just now we found the f of c value. Now we are going to check the whether f of c is coincides with the left hand limit and right hand limit. Okay, now the close values of c, no. So if it is 5, no, the close values of minus 5 in the left side as well as right side is going to be what, very very close values, are anyway less than 1 only. Okay, so that means for finding the left hand limit also we are going to replace first function, and finding the right hand limit also we are going to replace f of x as the first function. So instead of finding it different separately, so we can combine together and we can find it out. Okay, so that we can able to save the time. So limit x is approaching to c, f of x, so suitable f of x is x plus 5, first function. Now replacing x as a c, that is c plus 5. So from this we can say f of c value and limit x is approaching to c, f of x, both are same. So that what we can say from this f of x is continuous if x is less than 1. F of x is continuous if x is less than 1. Now in case 3, which is left over now, we didn't check for all the values. As of now we have checked for at x equal to 1 whether function is continuous or not. If x is less than 1, function is continuous or not, we check. So this interval is still pending, so we have to, in case 3 we are going to check for this, if x is greater than 1 whether function is continuous or not. If x is greater than 1, so greater than 1 also, as I told, for less than 1 the same thing applies here as well. So for greater than 1 also we have infinite real values are greater than 1. So that means for one by one value checking is not possible, so we are going to have a commonly as a c. Let c be the any variable is fine, but here I am taking it as a c. So let c be the any value, c be any real value, at the same time c should be greater than 1. Now to check the continuity, no, what are the things is required? F of c is required, left hand limit, right hand limit. Now f of c, so when x is exactly c, no, c is a greater than 1, then suitable function is second function, c minus 5. So f of c is c minus 5. Now left hand limit, right hand limit, here let's take any value. Okay, like 10, let's take 10. 10 is a greater than 1. Now the close values of 10 this side as well as this side 9.99 like that, and this side 10.1 like that. So both are anyway greater than 1. Okay, so that means greater than 1 means we have to take the second function. So here for example, for understanding purpose I have taken it as 10, but actually c only we must have. Okay, so left hand limit, right hand limit combinedly we can able to find out now. So limit x is approaching to c, f of x. So what is f of x? Second function, that is x minus 5. So replacing x as a f of x as a x minus 5. Now applying the limit we can able to get the c minus 5. Now from this what we can say, f of c value and limit x is approaching to c, f of x, both are same. So from this we can conclude f of x is continuous if x is greater than 1. Now from above all three cases we have to conclude that in a case one, what we concluded, f of x is not continuous at x equal to 1, and in case 2 the conclusion is f of x is continuous if x is less than 1. Same way in case 3, f of x is continuous if x is greater than 1. So from above all three cases we understand that x is f of x is discontinuous only at x equal to 1. Other than 1, remaining for all the real values, the f of x is discontinuous. So that's all the solution, and thank you for watching, and please do subscribe, and the next sum will continue in the next video. Thank you.